what it is called. We have, this is experimental techniques. Experimental techniques. The topic will be transducers. So it transducers. So you might have heard about the terms generally, which we call as sensors. Sensors. For example, you have in your lab, if you have in your experimental lab, you have an experimental lab in of your MSc class, and you do an experiment. You give some voltage. You give some voltage, and you want to measure it. You want to measure this voltage. So when you want to measure this voltage, you need a device. You need a device which senses this voltage, which sense voltage. That means it should know that voltage is coming and then measure. And any device which senses a physical quantity or a physical signal. So it senses actually a physical quantity. This physical quantity can be any, like thermometer. You have a thermometer. It senses actually temperature, which is actually the content of heat. This. So this is content of heat. So you all have actually seen these devices, and you all have been able to identify these devices based on their principle of working, what they do actually. So they sense actually. So in general, if I want to define a transducer, the definition of a transducer is that which converts, actually transducer converts one form of energy into other. One form of energy into other. It is converted by a transducer. So that is a transducer. And in sensor, why I discussed the sensor actually, sensor and an actuator. These are two terms, sensor and actuator. These two are opposite of each other. One senses the signal and another one converts the signal back to that sense actually. So since these are forms of transducers. So these are actually the forms of transducers. So when we have these types of sensors and actuators, they act as actually transducers. So in general, we can say that a sensor can be called as a transducer. How? Because if I go to this example, or voltage to voltmeter, then this example, you can see that we have heat in the body, or heat of a system. For example, heat, it is measured in degree centigrade. So it forms one to can measure that. So we have a thermometer, there is a sensor which senses that heat. We have any signal, the potential difference, it is measured in terms of voltage. So potential difference. So in that sense, a sensor can sometimes, or most often, is referred to as a transducer. And what is sensor? It actually senses any signal. So sensor senses a physical quantity or a signal. Then what is an actuator? An actuator, it converts a signal, generally an electric signal. It is electrical, to a some action. Action may be mechanical. It converts a signal which may be an electrical. For example, if you have a DC motor, what it does, it takes an electric input and converts into some mechanical, into some motion. It rotates, it moves some parts from one point to another point. So this can be an actuator. So we have a sensor which senses the physical quantity and gives you the output. And we have an actuator, it converts some quantity into another. So these both are the forms of the transducer, and in general both do the same work. What they do actually that they convert one form of energy into another. For example, you have in the experimental lab a CRO, cathode ray. What it does, you measure different quantities on the CRO. You measure it voltage, you measure currents, you measure frequencies. Lot of quantities you can measure on CRO. So there are transducers which are combined into that system, into the CRO. So transducer in general, you can represent that any which form converts one energy into another. Sensors and actuators, they are actually the forms of a transducer. So they are actually the forms of a transducer. In general, if you want to see that what is the exact difference between the sensor and, sorry, how they are same. First, we will see that how they are same actually. They are same actually in the principles, sensor or a transducer. They are same, basic principles are same all. Same. Basic physics is same. The principle of working is same. That means if you take a simply in the name of a sensor, that we need a sensor which senses the temperature, because most of the temperature which you measure in your experimental systems, in the lab equipments, there are actually those voltage sensors or temperature sensors. You give a current to the system, you get the output is in terms of a heat or in terms of a voltage. So those are actually which convert that, and they sense this and then convert back. So that whole system is then called as a transducer. So basic principle actually is same. What the principle applies to the sensor, same principle will apply to the transducer. Same principle will apply to the transducer. So what actually the difference is? If we see the difference here, अगर हम difference देखना चाहते हैं.
Efficiency.
Yeah, there is a one point is that we should have an efficiency. The efficiencies are different. For example, in case of sensors, there's, if you want, the sensor is to detect and measure, and whether its efficiency is, whatever its efficiency is, doesn't matter. The efficiency of a sensor is immaterial. Immaterial means it is not important. But for a transducer, it is important. It is important. So for a sensor, it is immaterial, but for a transducer, it is important. One point. The another point is that is called as linearity of response. What we mean by linearity of response is that it is plotting the output versus input. Output versus input. That means the linearity of response means that we should have, and when we plot the output versus input, what we see that it should be for a sensor. If we go for a sensor, this output versus input for a is likely to be important for a sensor. It is important for a sensor. Remember that when we plot output versus input, we should know the quantities and their units, what their units are. So it is important for a sensor, but for a transducer, it is not important. It's not essential. So it is not of much significance, actually, not of much significance. So it's not of much significance. So these are generally simple, the differences between and similarities. So in most of the cases, so these points actually, these are some basic points, but what is actually important is that the basic principle will be same for both the case of the sensors as well as the transducers. Then we have different classification, how we classify actually. Sorry. Then we have classification of sensors or transducers. They are classified differently depending upon various factors. Like if we want to see that different modes of classification are there. Number one is we can classify them depending upon the conversion principle. Conversion principle, or the principle which is used. For example, a thermometer, it detects heat content actually. Sorry, it is conversion principle. So it detects actually for a thermometer, we can have a heat content in case of temperature. We can have heat content in case of temperature. Or for example, in a this we can have resistance for heat measurement or temperature. It depends actually. So these become actually electrical ones. These become actually thermal here. So these are electrical and these are thermal. So it depends upon what is your principle of conversion. You can have magnetic principle where the magnetic quantity is involved for in the case of a this magnetic needle. For the case of a magnetic needle, or that this which is used for that Biot-Savart law, magnetic needle. So the simplest example I will tell you of a transducer is that an electrical switch, bed switch, which is used in households. So this is a simple transducer. If your mechanical energy is converted into the electrical energy, because you turn on and off, so it converts your mechanical action into some energy. So you see different, so it converts your mechanical action into that input and output, on and off state of that. So it is a simple transducer, electrical switch. So we can have different starting from a needle, magnetic needle, to the highest of the microprocessors. Microprocessor is computer-based sensors are the transducers. So these are different. For example, we can have optical ones. We can have mechanical transducers. We can have gravitational, which are based on the gravitational signals. We can have electrical, which is one of the important, which we will study actually, this electrical, and optical as well. We can have thermal. This we too have to study. Thermal and magnetic is there as well, which I have already mentioned here. So not all are actually, we do not intend to study all in the detailed analysis, but what we will consider mainly those where an electrical signal either in the input or output is measured, and some of the basic principles these and some of the basic conversion principles are the basic physical quantities which are involved these. So these we can see, and as well as this thermal. So these are some of the basic transducers which will be studied, where the principles regarding principles of optics, mechanics, gravitational, electrical, thermal, and magnetic. These are some of the which are mentioned in your syllabus as well, and we will discuss them. Some of the examples. Actually, we cannot go and study all of those. Basic principle will be same for every transducer, but some of them are most important, or which are most oftenly used in the industries, in the research. We will discuss some examples about from them, and then we will be able to understand their basic principles. Sometimes we have, for example, like we have active or passive transducers. So active means if you don't need an electrical input, if you don't need an electrical input, then it becomes an active transducer or sensor. If you don't need an electrical input, for example, then what you need actually, what it converts then, for example, photovoltaic cells. You have photovoltaic cells, thermocouples. You have thermocouples. Thermocouples we will discuss later on. So you don't need an electrical input for any transducer or a sensor, and then we need some other source, then it becomes an active transducer. For a passive, you need an electrical input. Electrical input. So you need for a passive workers, passive transducers, you need an electrical input which it will convert to some different. It can also convert it to the same electrical output. And then if it converts, if we have same form of energy as an input and same output, these are called as modifiers. These are called as modifiers. What they do actually, they modulate the voltage, current of a supply. जो आप supply कर रहे हो, what we supply actually, they modulate that, they modify that input, whatever you are using. So that's how we define actually them. So there's electrical input, these are called as passive, and in this passive case we have modifiers. And sometimes we don't need an electrical input, so those are called as active or self-generating. These are also called as self-generating transducers. That means they generate the output in case of by self of the generate that electrical output or any other form of the output. Then we have, for example, in modulator, if you have a modulator or a modifier, the example of modulator or a modifier is that of amplifier. Sorry. Amplifier or an audio amplifier, simple audio amplifier, where there is also variation, where we measure actually the variations of oscillations. Okay, so I will answer the initial question later in the end. Please remind me. So I will answer your question at the end. How we call actually transducer is simply, it does not only convert the electrical energy, it converts any form of energy. If you see the definition, of the above, it converts any form of energy. If you remember that your notes which I have sent you yesterday, you see the definition of the transducer is that it is any device or any machine or any component which converts one form of energy into another. So it is not that only we convert the electrical energy, but it converts any form of. When we have only electrical, when you need an electrical energy to convert input, at the input, it becomes a passive this passive transducer. If you don't put this electrical energy in the input which you need to modify, or it is called at that time, it called as passive. If you don't put some input as an electrical, it becomes active or a self-generating. If you need an electrical input, it becomes a passive one. So it's not only that it converts only electrical energy. Transducers convert any form of energy to other form of energy. Mostly it is electrical, and mostly in the output it is mechanical, but it is not restricted to that. So we can have a variety of energy form conversions. That's why these are called as transducers. So for example, the example of a modulator or a modifier is that you measure the variation of oscillations of it in a diaphragm of a microphone diaphragm. What it modifies your audio signal, and it gives the same audio signal in the output. So that is how the modifier, it modulates your input signal. It modifies that and gives you the increased amplitude in the output. So that is an example of a modifier or a modulator. We have nowadays, there are more, depending upon the technologies used, we have smart or intelligent, these transducers. What are these actually? These are based on the modern day technologies. modern technology of microprocessors. Microprocessors, that means they are integrated along with the computer microprocessors to increase their efficiency, to increase their conversion efficiency, or to increase their speed of working. So they are converted into this, and we have advantage of these, which will we discuss. Actually, the error is less. Error is less here in these cases. So let's move on now to another point, that what it is called. There are some two important points that I will write it as characteristics. These are characteristics. Actually, these should be associated with the transducers. That means we can measure these things when we talk of transistor. These transducers, not transistors. Sorry. One is resolution. You all know these things. Actually, this is why we read it now. We understand it from the basic view, basic point. If anybody has some audio or video issues, please let me know. If any of you have any issues, please let me know. Just message me. Resolution. So resolution, you know already what is the definition of resolution. It is that the limit or the ability to detect a change in sensed quantity or a measuring quantity in sensed quantity. That means how it detects, how small change it detects, how small change it can detect. How small change it can detect. So that means we should know that what is the resolution of a transducer, or what is the resolution of a sensor. For example, you have those sensors. Actually, the voltmeter is simple sensor. Voltmeter, it senses the voltage and gives you in the output the difference. And you have some emitters there. You have that temperature controllers in the dielectric setup जो आपके lab में है, which is in the lab. It has a that meter which gives you the capacitance. So that is simple type of this. That is one of the types of the transducer or a sensor. So sense and give you to the output in the different form. That is how we relate sensors and transducers. So ability to detect small change, how small it can detect, that is its resolution. Or it can sense. It can detect or sense. So in some cases, it may be infrared. Infinite means that, for example, what I mean by this infinite is that it's not that it can detect a large change. It is that the smallest of the smallest it can detect. That means if you have a small change in the input, there it gives you small, very small change in output. That means it measures the smallest of the smallest in the output as well. So there is no this distortion of the output when you measure some signal or some quantity, physical quantity, by a sensor or by a transducer. So that means whatever the smallest change will be there, it should be observed very well in the output. So if there's a small change in the input, it gives you that small change as well in the output. So these can be measured during the measurements. So that means it can be infinite, but sometimes it cannot be infinite because there are some errors. The resolution is actually limited by that error then, as that at that time. Then we have, for example, sometimes we have, if you have this is the case when you have, for example, if you have two types of these measuring devices in the lab. One is that you have analog, one is digital. If you are measuring a physical quantity by an analog meter, that means you have an analog meter, you are not you are not sure about what is the exact value. So sometimes these analog values, these cannot measure some of the quantities, but in that this cannot measure the smallest values. You are not sure about how small it measures, but in this case, in this what it is called, the resolution of the analog scales or analog sensors is small sometimes, and these digital are actually they are low. So what does it mean? That it means that you have some quantities which are measured on the digital output devices, digital devices. So on those digital devices, you are not sure about what is the resolution of the transducer inside. So at that time, it depends upon the resolution of analog to digital converters. That means ADC. So because there's a conversion, because these are as well, these are the transducers. So these converters, we should know the resolution or the limit in the measurement of these devices, analog to digital converters at that time. Another point is that what we should know actually, what is the error? Errors you have already studied actually. There are those are the same errors which we have discussed later, but in terms of transducers, these may be sometimes static or dynamic. Okay, so we are okay. So all of you able to are all of you able to hear?
Yes, sir.
Okay, okay, good. Thank you. It was actually disconnected due to some network problem. So, so the errors in the measurements by the transducers are during the conversion of one physical quantity into the another is that we can have static error or we can have dynamic error. By static or dynamic, what we mean that in static, for example, you are measuring some physical quantity during the reading actually. Error, sorry, wait. Okay, no problem. Let me leave it here. So we can have, by static, what we mean, caused by reading problems. It is caused by reading problems. That means you are not able to read correctly what the exact reading is, which we have already discussed in the class, which is also called as parallax. For example, I have already, you know all these actually. If you, this is a analogy, this is your analog, that meter, and you try to measure that this value, this. You don't know exactly what it should be because you have one scale here, one is here. So you are not sure about. So if you view this signal from one angle, and if somebody views it from here, he will find it at one position. If somebody views it here, he will find it at different position. So that means it is at different positions because of the different viewing angles. So that is called actually parallax angle. So you are not able to measure it correctly. So this becomes a static error actually. And so this is makes a problem while measuring by the observer. And when that means the observer which is measuring this type of quantity is this type of quantity, at that type the error is called as, it becomes a parallax error. The another point is that another error of this type is the interpolation error. Interpolation means that if you have studied interpolation, for example, you have a set of datas. This is, you have one, you are plotting this type of, so you have this type. So interpolation, that you know what is the value of, if this is x, some quantity, this is y. You know the value of y at this x. You know the value of y at this x. You know, for example, if somebody tells you that find the value of y at this point, somebody tells you that find the value of y at this point, which is not given in your data set. So what do you do actually? You take these two approximations and find the midpoint between them. You can take the midpoint between them, and you're not sure about where should it lie exactly. You are not sure about what is the exact data point which should match between these two. Same is called as interpolation. It is called when you find an extra data point in between the given set of data. डाटा दिया हुआ है, it is आपको निकालना इसके दरमियान एक और कोई डाटा पॉइंट. When you go out of that range, for example, आपके पास यहाँ पॉइंट है, आपको बताया जा रहा है ग्राफ को एक्सटेंड करो, देखो कैसा आ रहा है, तो you can go up to here. So this is called extrapolation here. This is when you find another data point in between the given set of data points, it becomes interpolation. When you go beyond that given set of data points, it becomes extrapolation. So interpolation error is means that you do not know what will be the exact value when you have the two extreme values like this. You know these values, but you are not sure about what is this value in between those two. So this becomes an interpolation error, and this is of the static nature. And these are different types of the static errors. Then there are another error of it is the interpolation error. So in case of this is for the analog. So when you have a digital meters, when you have digital meters, so what you will do actually in the digital meters, you do not know actually if there is an interpolation error, because whatever you get the exact value. It doesn't mean that they don't have the errors. So there are errors. As I earlier told you, the resolution as well as the errors, they are controlled by analog to digital converters. These are controlled by analog to digital converters. And sometimes you don't know actually if you get a value 1.255 from a digital reading and it is varying, it is fluctuating at this point. So you are not sure if it is 1.255 or 1.256. So this type of errors can happen when you have a digital readout, when you read it on the digital scales. So these are some of the static errors. Then we have some dynamic errors. Dynamic errors means that you measure some physical quantity. It is actually actual quantity minus measured, simply, which is called as relative. Actual minus measured. Sometimes you are called as that as a relative error. And it is because it varies actually. This error, because it changes. It depends upon how the efficiency, what is the efficiency of the instrument at a particular operating point. Operating point means when it is working, if the load is changing onto the system. For example, you have different you are working on some instrument. For example, see simple the dielectric constant, that experiment. For example, the dielectric constant experiment. So if the you use those power supplies, if you remember, power supply regulating power supply. Regulating power supplies. Why you use those regulating power supplies? You want to minimize the fluctuations. You want to minimize those fluctuations. When you want to minimize, why you want to minimize? Because if the input load increases, your output will vary, and you will not be able to see the exact situation, what the exact situation should be. So you're not sure about that. So that is why it is called as dynamic actually, because it depends upon the load of the system. What is the load of the system at a particular instant of operation, at a particular instant of time? So that means we should know that our input, or wait, I will see the message, load. Okay, no problem. I will continue. I will tell you. So that means if we have a regulating power supplies, we need to use them because there should not be any fluctuation during the measurement. When there's a fluctuation, there's a fluctuation in the output. That is why some people say that, sir, point if graph should be like this, it goes like somewhere here. So these are actually because due to those errors, because these are dynamic. They can happen at this point. They can happen at this point. They can happen at this point. You are not sure why it will happen. So it depends actually how the conditions or the input parameters or the output parameters vary because of the working conditions. Those are the working conditions actually. Sometimes it happens like, for example, if you have a voltmeter or a meter, and these have different resistances. Actually, you know that, you all know that. So if the resistance is high, sorry, resistance, if resistance changes during a measurement because of the different input current voltage, if resistance changes because of the different voltage and the different currents, you can get a different value. You don't know, if you don't know the resistance, what is the resistance during a particular